So next homework I'm going to review is homework number 29. I'm going to do 4 problems, 4 example problems from that. So this homework covers comparing compound propositions. So in the last videos that I did, we were just translating compound propositions into standard propositional logic form, like these ones here. And now we're going to compare 2 different statements and see if they're what category they fall into: logically equivalent, contradictory, consistent, inconsistent. So the first problem, number 1, I'm doing number 1 and number 2 first from homework number 29. We're going to do full truth tables on these, and I've already filled out the beginning, the truth tables under each of the simple propositions, so each of the terms. And since we only have 2 terms in each of these 2 statements, A and B, you're going to have 4 rows of your truth table. 2 to the second power is 4. So the first statement is not A or B. Second statement is it is not the case that A and B. And so, like in the other videos I did with full truth tables, I find it helpful to first identify what our main operator is going to be. In this one, our main operator is going to be the disjunction. Not A is a separate entity, B is a separate entity, and what combines them is this disjunction. It is not the case that A and B, the main operator, is actually going to be the negation, this tilde. A and B is a separate, those connected by the conjunction is a separate entity in itself. And you're saying it is not the case that proposition. So we're going to know that this column under the wedge and under the tilde are going to be the main columns that we're looking at. So let's go ahead and fill out the rest of the truth table, what we know. So first thing, we can do this negation, which is just the opposite truth values. So false, false, true, true. And like I've showed in other videos, what I kind of like to do is just so it doesn't get cluttered in my head. These are pretty simple, but some of them get much more complicated, is just kind of go through and lightly cross out. We're not going to need the column under the A anymore because we're looking at the negation instead. So now we're just down to these 2 columns and we're looking at the disjunction between them. So disjunction, either one can be true for the disjunction to be true. So it's okay if they're both true, but if they're both false, the disjunction is false. So here the B is true, so that's true. Here both of them are false, so the disjunction is false. They're both true, so the disjunction is true. And not A is true here, so the disjunction is true. So let's go ahead and just circle that column so that we know that's the one we're looking at. And over here, we have to do the conjunction first because that's within the parentheses. So to be true, they both terms have to be true. So that is the case in the first row, but all three of the other rows have one of the terms being false, at least one of the terms being false. So it's true, false, false, false. So again, if you want to just kind of lightly cross out the columns we're not going to need. So we're just negating this column here, so it's going to be opposite truth values. So false, true, true, true. And we can go ahead and circle that column because that's the column under the main operator. So now we're just comparing these 2 main operators, or 2 columns underneath the main operators. And so just to review real quick, logical equivalence is when these two columns have the exact same truth values. So true, false lines up in every row. Contradictory would be the opposite of that. So they'd have to be the opposite, true, false, false, true, whatever, in every single row. If it's not either of those two, you move to consistent and inconsistent. Consistent means that once you've already established that it's neither logically equivalent or contradictory, consistent means that there's at least one line with both of them being true. And inconsistent means that there's no row where both of the statements are true. So this one, we can look at logical equivalence: true, false, true, true, false, true, true, true. They're all scattered, so we know that it's not logical equivalent or contradictory. Well, just to highlight that, let's go ahead and put an X in both of those. Consistent or inconsistent: is there at least one line where both of them are true? This is true, this is false, so it's not that line. This is false, this is true, so it's not that line. This is true, this is true, this is true, this is true. So the last two lines, both of the statements are true. So we do have consistency. So these two statements are consistent. Let's go ahead and erase that and move to the second one. So filling out the truth table of this one, it's pretty easy. Just the conjunction of these two, so they both have to be true. So we have true, and then we have at least false, one false for each of the other three lines. So that one, since the conjunction is the main operator, we're looking at this column here. The second statement, the negation is going to be the main operator. So let's just do the disjunction of A and B. Disjunction means either one can be true for it to be true. We have at least one true there, one true there, one true there, and these, both of them are false. So you can kind of cross out the two columns that you're not going to need. And you're just going to be doing, this is a negation of that disjunction. So it's just opposite truth values. False, 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 true. And since that's under the main operator, that is the column we want to look at and compare. So let's compare these two. Are they logically equivalent? Well, you have two false, so already logical equivalence is out. Contradictory, you have true, false, okay? False, false, those are the same. So already contradictory is out. Consistent, are they? Is there one row in which they're both true? True, false, no. False, false, no. False, false, no. So they're both false. False, true. You have a false here. So there's no row in which they're both true. That means that number 2 is inconsistent.